All right, ladies and gentlemen, welcome back. We're going to be talking about Chapter 10 now. Okay, so just a quick overview of Chapter 10. We're actually going to be doing 10.1 in this video. But I want to start by introducing Chapter 10. So Chapter 10 is 3D shapes. Okay, so whereas we've been working with 2D shapes, in this case, we're going to be working with three-dimensional shapes. Okay, so if you don't know I think most of you know the difference. Okay, so we're basically going to be finding two different things. We're going to be finding surface areas and volume. Okay, so that being said, by the way, we're not going to be doing 10.6. So you can expect for this week. Here's how it's broken up. We are going to do these three. Man, I'm really bad at those. Let me try again. We're going to be doing these three because they are all surface area. That's much better. They're all surface area. And if you understand how to do surface area of a prism, you can also easily, hopefully, translate that to cylinders and pyramids. So be prepared. This week's going to be a little bit more challenging just because you're going to have an extra homework. But don't worry. I will take that into account in how many problems I assign you. And then you will have a quiz over that. Okay, so that's what we're doing this week. For today, we're going to work on 10.1, surface area of a prism. Okay, so these 3D shapes, okay, there's different types of 3D shapes. This is a prism. Okay, so what makes a prism a prism? Well, a prism is a three-dimensional shape, like we said, that has two bases. Okay, so that's important. There are two bases, and those two bases are parallel, and they are the same size and shape. In other words, what we're going to find is as we're finding the area of a geometric prism, okay, there's going to be two bases, and when we find the area of the first base, we're just going to multiply it by 2. Okay, so that's how that helps, and then. So they are the same size, that's why we know that, and shape, so therefore they have the same area. The prism's sides, so the sides are all parallelograms, and this is the key to what makes a prism, okay, is that the sides are parallelograms. So let's look at some of these, okay? So these parallelograms, by the way, are called the lateral faces. Okay, we'll get to that. All right, so if you look at this, you've got a triangle, and this is colored in orange, and that is the base. Okay, this is the pup tent that they're talking about. So you've got a triangular base, and if you can imagine the parts you can't see, let's draw it in dotted lines. On the opposite side of the tent, there's another, and I would have gotten orange if I had all the fancy colors. There's another identical base just like it, and it is a triangle. So since the base is a triangle, it is called a triangular prism. Since this base is a square, okay, and we can just imagine that this goes back to the other side. And this side back here is a square. Since these bases are a square, it's a square prism. Since these bases are, let's see which ones are my bases here. I'm not even sure. Let's say that this is kind of a funky one. So if this base right here and this base right here, okay, so you can kind of imagine that. Those are rectangular, so that is a rectangular prism. Okay, this here is a pentagon, so it's a pentagonal, and a hexagon is a hexagonal, and an octagon is an octagonal, okay? But no matter what, let's do this in red. No matter what, this is a face, and it is a parallelogram. This is a face, and it is a parallelogram. This is a face, and it's a parallelogram. Parallelogram, parallelogram, parallelogram. Okay, now if we look at some different ones, when we get down to these pyramids, okay, we have the same thing. We have our triangle here, right? But this face is not a parallelogram. It's also a triangle, right? In fact, we're going to find pyramids have triangular faces, and they have a single base, right? So, anyway, we'll get to that. Okay, so again, those are your bases. These kind of help you look at them differently. These are your bases. They're colored in. It's nice and pretty. You can tell that they are opposite each other. They're parallel. So, in other words, if I were to extend a line here, I didn't do this in my practice. So, if I extend that line, then this line here, okay, that same side, opposite side, those are parallel. Okay? So, they are parallel. They are the same size and shape. Does that make sense? Okay, and hopefully you can tell, this is actually a better one. Hopefully you can tell that these shapes, right, are parallel to each other. Okay? If you think of a box, go get an Amazon box. I know your parents have one. Look at how they are parallel. Remember, parallel means that they run, parallel lines mean that they run across and they never intersect. Okay? So the sides, the bases are parallel. I think that's an important thing for you to know. Not for this chapter, but just so you know. And I like to tell you stuff just so you know. Okay, so I moved this up because this is the basic formula for all of the prisms. It doesn't matter which prism you're working with. You find the area of the two bases. Okay, there's 2 times the bases because that was our definition. You find the area of the 2 bases and you add together their faces. Okay, so the bases and the faces. Bases and the faces. The bases and the faces. All right, so there you go. That was goofy, and now you're going to remember. The bases plus the faces. But you're just adding them all together, right? Okay, so let's look at what this looks like. Okay, so here's the deal. This thing here, as I've already written net, this thing here is a net. Okay, so if you haven't, let's pretend this is an Amazon box, okay? You guys have seen a lot of those lately, probably, or at least a couple of them. I know I've seen several. They don't go through the Amazon machine and they don't make them into boxes. They start them out flat like this. And then another part of the assembly line then folds it up. So if you wanted to be a box maker, you would need to understand the net. How do I make a net that folds into a box? Okay? So I find this to be, in my opinion, I think that this is very complicated. It's very complicated to make a net. Okay, I think it's much easier to look at the 3D shape, and that is how I'm going to teach you. I'm going to post a Khan Academy section or video that if you want to learn how to do it with nets, he does talk about nets. But I think even him, if I remember when I originally first went through these, I think even he kind of looks at it as the 3-dimensional shape. So we'll get into that. But I will say this. If they give you a net, use it, okay? Because it's very easy. What's the area of this? 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 And what's the area of this? And you're done, okay? So if it gives you a net, by all means, use it, okay? But making a net can be confusing and you can actually make errors. So the chapters teaches you how to make nets. If you want to look at that, go to your ebook. That's another resource if you want to learn how to do the nets. And if you want to be a box maker, you definitely need to understand this. Okay. All right. So this right here is kind of what I was talking about. I don't want us to dwell on this. I want us to just remember that it's the area of the bases plus the faces. Okay, because that's the more important part. Okay, so if you note on our success criteria, we need to know surface area and we need to know lateral surface area. Okay, so what is lateral surface area? The lateral surface area does not include the base. So it's like the Amazon box if you cut the top and the bottom off. Okay, it's like actually, here's a perfect example. It's like this thing. Okay, we'll get to that. But if you see, there's not a top and a bottom on this. Okay, it's like it's a fly trap or whatever this thing is, mosquito trap. Okay, so that would be the lateral area because we do not include the bases. So what does that look like? Well, that basically looks like since we don't have this and we don't have this, all it is it's all of the faces. The faces, no bases. That's the lateral. Area. Okay, it's the faces, no bases. But I don't like that. I like the bases and the faces. Okay, so let's do one. You guys are like, dude, just move on. We're trying to get this video done. Okay, so we're going to find the surface area of a rectangular prism. It is a rectangular prism because this is a rectangular, and that is our base, and there's another base. These are our bases, and they are rectangular. Therefore, it is a rectangular prism. Therefore, when we find the surface area of a rectangular prism or any prism is the area of the bases plus the area of all the faces, right? Okay, so we have the let's just do it. So and then we add them all together. It's super simple once you get the hang of it. It's going to be a bit challenging to do this on the video, but we're going to do it anyway. Okay, so this is a base and this is a base. Okay, and I'm going to look at the bottom base because guess what? The top base doesn't have any numbers next to it, but the bottom one does, 5 and 3. So therefore, the area of the base is length times, so at this point, you're like, what's the formula for the area of the shape that is the base? Well, since it's rectangular, it's length times width, right? And length times width is 3 times 5. But there's two bases, so 3 times 5 times 2, right? Because there's two bases. So this would be 15 times 2 or 30. Okay, so the area of of both bases is 30. Okay, now I'm actually going to move this plus over because the faces get a little more challenging. Okay, so yes, they gave me. So I've done this and I've done this. So yes, they've given me this sweet little net, but I don't think they do a single time in your homework. Okay, we can use it to check ourselves, I suppose. But I want you to look at this the way I look at it. Okay, so we've done basically what I would call the bases. Okay, or in this case, the top and the bottom. Okay, so we've done the top and the bottom. Let's call them a base. I mean, if I had colored this part in red, this could have been my base. It's still a rectangle. But anyway, so I've done the top and the bottom. So this is kind of what I do. This is the top and the bottom. Okay, we're the bases. Now I want to do the front. See this front part? Okay, and what corresponds to that? This back part, right? They're the exact same. It's 3, and this is 3, right? So those are the sides that are the same. That's the width, and then this is the length or height or whatever you want to call it. And that corresponds to this back here, right? So length times width is 6 times 3, and those are the same because they're the same length and width, right? So the front, so the faces, so these are the bases, and then the faces, we have the front and the back, so I'm going to abbreviate it F/B. The front and the back are simply 6 times 3, which is 18 times 2, right? Because there's 2 of them. So that would be 36. Okay, and then we're going to add, and you don't have to color all these in every time. You'll kind of start to be able to just look at these. So we've done the top of the bottom, and then that one was so see how this is confusing? So we just did the 3 times 6, which is this one and this one. So those are gone. And that leaves me with 2 other parts, which is this and this. Okay, but look over here. All these are the sides. okay, the sides of this thing. And you can call it whatever you want, but this side and this back side, okay? Rectangular prisms are the easier ones of them, okay? And they are, well, this, here, let's use a different color. So this right here corresponds to this right here, so we'll call this the, I don't know, the base. Let's call this a parallelogram rectangular. So this will be the base is 5, so length times width will be 5. And then we have this side right here would be our height, or our length, whatever you want to call it. And this side right here. And those are both 6, right? They're the exact same length. They're both 6. So on our sides, we have 5 times 6, and there's 2 of them, right? They're 2 identical ones. And if you look at my little fun little net, that is 5, and then this side and this side are the same by 6, right? So this would be 30, and this would, wait a minute, sorry, and this would be 30, right? So check, check. 30 times 30 is 60. Okay, so now we add them up. So we have 30 plus 36 plus 60. Now, I'm going to use commutative property, and I'm going to add these two first because I can do that quickly in my head, which is 90. And then 90 plus 36 is 126. And for the science teachers who love their units to be correct always, this is square inches because it's area. Area is square inches. Volume is cubic inches. So once we get to volume, then we'll have cubic inches. Okay? All right. So now this one's kind of a funky one. Okay? And it's funky. They really just escalate things on us hardcore here. So this one has different sized everything except the base, okay? And that's what makes this one a little bit tricky. So we have surface area is equal to the area of, we'll say the A of the bases plus the area of the faces. I know this is super cringy, but you love it. All right, so my bases are triangles. So this is a triangular prism, right? So so am I going to do length times width? No. I need to know, so the formula I'm going to be using is 1/2 base times height because that is the area of a triangle. That's the formula for the area of the triangle. And then once I find that for one of the bases, there are 2 bases. Times 2, okay? And then the faces are parallelograms. They're always, that's the definition of a prism. They're parallelograms, so they're going to be length times width, okay? But if you look over here at our little net, okay, let's look at our net, you can see that we do have 2 identical triangle bases, but that all 3 of our faces are different, okay? So we have a bottom, which is this over here, right? We have a the purple's apparently on the other side where we can't see it. Okay, so the purple, we've got a bottom, but either way, we've got a bottom and we've got a side. Let's call this the blue side, okay, and then we've got a green side. Although I would call the green the bottom, but you can call it whatever you want, just as long as you identify that we're not multiplying any of the faces by 2. Okay, so in this case, they gave us this thing. This is great. So let's see here. It's going to help us check things off. So what's 1/2 the base times the height? Okay, so if you weren't looking at this, thing right here, they get a little confusing because this 5 actually has nothing to do with what you need for this triangle. Because think about it, let's draw this triangle down here. Okay, let's do it in red so it matches. I like to be color coded. if you look at just this triangle, if I pull it out, that right angle means that this is the height. Therefore, this is the base. So therefore, this was the base, and this is the height. So that 5 was irrelevant, which I thought was another reason why this one was kind of a tricky one to do on the second side. Okay, so let's rewrite green. Okay, so let's see. So it is the 1/2 base times height, right? So the base is 3, the height is 4. So we have 1/2 times 3 times 4. I'm going to use and then times that by 2, right? Because there's 2 of these triangles. Okay, so I'm going to use the commutative property again and do 1/2 times 4, because 1/2 of 4 is 2. 2 times 3 is 6. 6 times 2 is 12. So again, 1/2 times 4 is 2. 2 times 3 is 6. 6 times 2 is 12. So we have 12 is the area of the bases, okay? And now let's look at the bottom part, okay? So we have a bottom and 2 sides. I don't really care how you look at this. You have a bottom and 2 sides. Gosh, I don't like they turned this up. Okay, so whatever you want to call this green thing, okay? The green, okay? You know what? Let's just color code these, okay? And guys, I promise you, you can do it however you want. As long as you account for the faces, you will get the right answer, okay? So plus the green face, okay? The green face is length times width. Well, we know that this is one side is 3. So that'd be plus 3 times whatever this is. Let's do this in red. Whatever this side is, which if we look across, makes it 6. Okay, so 3 times 6 is 18. All right, and then so we're done with the green. Now let's do the blue. I just wrote. I could have done these in colors. Boy, that eraser's huge. And I am not starting this over. Okay, sorry about that. So now we're going to do blue. And then the fake purple that we can't see. Okay, so those are our sides. Alright, but just keep in mind, length times width. Here, how about you make the eraser smaller? Okay. Thanks for bearing with me, guys. It's really difficult to restart these videos. I've already done this video twice because of other mistakes. Not mistakes, but just messing up. Anyway, okay, so let's do the blue. That's over here. So we have a length and a width. 6 times 4 is 24, right? So 6 times 4, which is 24. So that's our blue. So if you want to look over here, we've done both of the bases, right? The bases were 12. So rather than checks, we could just write it. So we've got 12. We've got 12. We did the green, which was over here. And the green was 18. And now we just did the blue is 24. And now we just need to do this purple, okay? So let's imagine Mr. Purple. Okay, Mr. Purple. They did draw us a dotted red line, so that was nice. Let's see if we can find purple. Oh, look at that. So Mr. Purple is back here. Okay, Mr. Purple is the bottom. Okay, so Mr. Purple has a length here. Here, let's use a different color for Mr. Purple here. So, I feel like that didn't help. Okay, so let's use a, well, I don't know, red's fine. So Mr. Purple's got a length of 6 and a width of, well, what is this one? There's our 5 that they tried to make me think was part of my triangle, times 5. Okay? And that is 30. So this part was 30, and that therefore I have the area of all the parts of this thing. And you're like, Mr. Hines, this is confusing. I get it, guys. It is a bit confusing. If you have an iPad or something, I do like being able to erase like my work and then kind of and then rethink about it with a blank one. But if you don't, you can redraw it or do whatever you want. Okay, so adding all these up, let's hope we get the right answer. So we have 12 plus 18 plus 24 plus 30 equals 84. That is correct. 84 meters squared. Okay, remember area. Units are squared. Okay. All right. Moving on. I don't know why I'm pausing. Okay, so here's our lateral surface area problem. We're going to use a real life problem to figure it out. I'm going to have a drink of coffee. Okay. The outsides of the purple traps, we're reading this together, are coated with glue to catch the emerald ash borers. That's this guy. Emerald ash borers. We learned a new science-y thing. Apparently they're bad. They bore into trees, I'm guessing. So we don't like them. We're going to catch them in our little trap. You make your own trap in the shape of a rectangular prism with an open top and bottom. Okay, so this is our ladder. What is the surface area that you need to coat with the glue? Well, they're telling us to use the formula for the surface area of a rectangular prism to find the limit, but do not include the area of the bases. Therefore, we need the lateral surface area. That's what it's called. Lateral surface area. And this definition is one of those things where it's like, do you really need to know this definition? No. But I will say that on the standardized test that I took, I'm pretty sure that I remember seeing about math, I'm pretty sure I had a lateral surface area problem. They wanted to know if I knew the definition of that. Did I or did I not? I don't remember if I remembered that or not. But I do remember it asking for that. Okay. So, there you go. All right. So, we have this... shape, okay? So here's what I want to do first. I want us to look at this shape in three-dimensional kind of way, okay? So it's gonna look, oh, that's pretty bad. All right, let's erase that little part. Okay, so it's gonna, you guys should have seen me do this when I first started. I was so bad at these. Okay. So that kind of hopefully helps you see, I haven't gotten a ton better, what's what, okay? All right, so hopefully you can see the three-dimensional shape here. So we've got a bottom and a top, our bases that we don't need, okay? So I don't care about this part right here or this part up top, okay? So all I care about are the sides. Actually what I care about are, let's see if I can, all I care about is the front, this front, and then the opposite back. So we have a front and a back that are going to be identical, and we're going to find the area. So the surface area is equal to the area of the front and the back, plus, so the front and the back will be times 2, so it's going to be basically length times width times 2, right? We're also going to need to know these sides. So this side, let's do a different color. Okay, so we're going to need to know this side and kind of this side over here, right? So we have this and this. Those are going to be my sides plus my sides. All right, and there's 2 of those, and they are both rectangles too, so it's going to be length times width times 2. And then let's do, we already did red. What was red? The front and the back? Yeah, the front and the back and the 2 sides is all we have. So cool. So let's look at the front and the back The back is this back part back here, right? Let's do it in green so you can see it. This back part is back here, right? And it's green. It gets a little confusing, guys. There's just not an easy way to draw on a three-dimensional shape on a 2D screen, okay? But we'll do one at a time. Okay, so we have the front and the back and the two sides. That's it, right? Because the top and the bottom are gone. All right, so let's move on. So the length times the width of the front and the back. So let's look at this. So we've got the front and the back, okay, is this thing right here. And this thing back there. Okay, they have the exact same thing. It is 12 times, I don't know why I switched colors here, but we did. 12 times, well, what's this? It's the same as this, which is 20. So 12 times 20, which would be 240. And then times 2, which is 480. So the front and the back are 480, okay? And then we're going to add to it the sides. The sides are, let's actually use the right color this time. Guys, I can't go back just because I messed up the color, sorry. I would, if I could redo this, if I was a pro, I would redo these and my colors would match. My numbers would match the colors I used. Okay, so on the sides, we have this guy and this guy, right? The sides are easy to see. You can color those and they look all pretty, okay? So the sides are the same. Length times width. So we would have length, which is 20. 20, not 2. 20 times this width, or base, however you want to look at it. It's a parallelogram, right? Is 10. Look at me remembering to do stuff. And then times 2, because there's two sides. Do you see two sides? I see two sides. Okay, so times 2. So 20 times 10 is 200. 200 times 2 is, so plus 400. And that gives us, drum roll, 880. And that's correct. And it is inches squared, because we're doing area still. Okay, guys, that was a long one. You're like, just go take a break and come and watch this again. I can do FaceTimes with you guys, or not FaceTimes, Google Hangouts or Zooms, whatever you prefer, to answer questions. I'm not going to give you a ton, but I do want you to take your time on these. Okay, so that's my goal. Give you less problems, but make it where you take your time on all these and really think about it.